Thank you very much, Andrew. Well, it's a pleasure for me to introduce this third session with the topic of nuclear safety, and the message I would like indeed to convey to you is that it's a continuous learning process for all stakeholders, and thank you, Civic Exchange, to organize this forum that is right in the heart of this topic. First of all, I would like to come back to the question of energy. This is a photo taken from the NASA different satellites by night of the Earth. And obviously, there is a difference between the North and the South. The North seems to be rich regarding energy, the South seems to be poor. So the challenges we have in front of us, both for climate change and also for the response to the increase in the energy demand, is not only a question of comfort, of clean air, or second car, or fridge. It's also a question of humankind between the North and the South. And I'm very convinced of this point that we have to respond for the 1.6 billion inhabitants of our Earth that do not have access to electricity up to now. To do so, we have to, all of us, do some efforts toward a more sustainable energy mix. This means perhaps for the rich in the North to put the effort on the saving of energy, but for the South to increase their means. And in this future sustainable energy mix, if we look at globally at the world level, we have to take into account all the possible options. The nuclear as a massive baseload electricity production without emission of CO2 is one of these options. This option benefits of now more than 12,000 years of industrial feedback, years reactor. That means that if we had in the world 1,000 reactors, they would have worked without any trouble for 12 years. In fact, we do not have 1,000 reactors. We have roughly 430, as in the red block down the slide. And this slide shows all over the world, in red, the reactors under operation, and in green, the projects. And I choose to illustrate my words by this slide, even if it's from 2009, which is a little old, and of course before Fukushima, because I wanted to show to you that some of the countries are very big, very large green, gray area. It's the case of mainland China, of course, with a project and program of developing more than 100 new reactors before 2030, and something like 11 already in function. Some, like France, have already a large installed fleet and very few projects, so very little difference between the gray and the red area. And some of the countries have balanced, increasing their fleet with a half new. It's the case here, it's the case here also. So all this global picture may move and will probably move after the Fukushima accident, because everybody will be concerned about the cost, about the safety of the cost also, but definitely I'm sure that some very important gray area will remain if we do this map again, beginning of 2012. Regarding France, the only thing we can do is try to share experience, and I will be happy also during the question and answer to try to answer. We are 60 million in France, and we have a fleet of 58 reactors. If I may insist on one or 2 points, this fleet was constructed quite rapidly between 77 and 99, and it's highly standardized, all PWR. Now, since the beginning of this forum this morning, you know what it means, thanks to Michael, pressured water reactors. This standardization is an important point regarding my topic, which is the safety, because when you decide an improvement of such a device in the reactor to improve the safety, in the continuous learning process of the safety, then you can apply to all the fleet. And it's important for the confidence and for also the operator from the industrial point of view to have this standardization of the fleet. Regarding the relations between France and China, they are going on since 1986, especially in the Guangdong with the Diabe project that has already been mentioned, with an investment from Hong Kong CLP in the building. The first connection in 93, so since in fact 94, Hong Kong benefits of its 23% of electricity coming from the 70% part of the electricity produced in Diabe dedicated to Hong Kong. Then the partnership with the French technology of PWR reactors went on for the Lingao and now for the Taishan EPR Generation 3 under construction in Taishan, again with the same partnership with CGNPC, except that for the Taishan, and I want to mention it because it's also part of the increased learning process, we are now in the configuration, thanks to the authorization given by the mainland government, of creating joint venture between CGNPC and EDF to operate the Taishan plant, which was not the case at the beginning for Diabe. Now, what happened in Japan on March the 11th? First, it was not a nuclear crisis, it was earthquake and tsunami. So natural disaster that killed or made disappear more than 20,000 people. And in this context of course, human catastrophe, almost totally destroyed infrastructure, I want to say that people on site in the Fukushima Daiichi plant managed the crisis as efficiently and as rapidly as it could be possible in such a dramatic environment and situation. Then we can discuss and try to build up on the lesson and what could have been done better, etc. But first, respect to the work they did on the site during the crisis. I don't want to go into detail on the technical aspects, but in 2 words, this nuclear power plant dedicated to produce electricity went to a high-level accident because it was lack of electricity to maintain the cooling of the core after it has been very correctly shut down after the earthquake. And this lack of electricity came first from the disruption of the connection with the main grid due to the earthquake, and then to the failure of the safety system on site because not of the earthquake, but of the tsunami that flooded the situation. So the main reason of the accident, the building resisted correctly to the earthquake, was the tsunami. So let's have a look from the top. This is the site. This is the height of the hills around the site, and you can see that it has been digged so that the plant number 1, 2, 3, 4 here, Fukushima Daiichi, and 5, 6 here. The 1, 2, 3, 4 were something like 6.5 meters above the sea level. So when the wave came, it was 10 to 14 meters, and it flooded the 1, 2, 3, 4. Then you have the effect on the diesel flooding and the lack of the electricity, and etc. You know the story. I just want to mention that here the 5 and 6 were a little bit above 10 meters. I don't know the figure exact. Here it's 6 meters above the sea level. Here probably 10 to 15. So these ones were not flooded. So here is one of the lessons at least. When we build, think of what will come. A 10 meters to 14 meter wave was not predicted by some of the scientists in Japan. But some other knew that in the past, and precisely in 869, such a tsunami with such a flooded region in the same area already occurred. So the discussion here is not a discussion between engineers for the design. It's a discussion also implying some other stakeholders who are the scientists who were, for the one and for the other, not in agreement on the size of the waves that could rise this place in Japan. Now on site, we can say, I think, that the crisis is behind from the technical point of view. Level 7, we already discussed on this point, and the fact that it changed from 5 to 7, perhaps not at the right moment, but however, it's a major accident that can occur in a nuclear plant when the fuel rods melt. This is the case, and a lot of, let's say, at least some questions still remain open. Did the fuel went through the vessel? We have some information says yes, some others says no. Not everything seems to be up to now known, even by TEPCO on site, and there will be some international inspection, etc. The effects not only on the power plant, but in the area. And here again, some of the questions. Here are the evacuation zones. Probably 70,000 people concerned by the evacuation, and of course I wonder if they will be able to come back in their area and when. But also due to the wind and the rain, some plume that went over the 30 kilometers, and with some hotspots with contamination in cesium. So here again, some question mark, and as far as I know, I don't have the precise situation up to now. In any case, I don't want to minimize the impact neither on the plant nor in the environment and of the area of the accident. But, okay, major accident, but what will be the lesson that we can draw out of this? First type of lesson concerning the nuclear fleet under operation. In all the nuclear countries in the world, immediately the government asked for some safety reviews. It was the case in China, and running now, and the results will be known probably at the end of the summer. Also the case in France. Again, here the standardization helps, I think, to take into account and to implement the recommendation from the safety reviews. For example, in France, after the 3 Mile Island accident, Michael also described this morning, recombination hydrogen devices were installed on all the fleet. This costs a lot of money, but this was the feedback of the 3 Mile Island accident on the French fleet. In Fukushima Daiichi, as you know, the top of the building exploded because of hydrogen, and there were no hydrogen recombination device in the Fukushima Daiichi plant. Lesson number 2, if I may, for the new builds. This is my personal opinion, but between short-term profits and safety, choose safety when you have, during the design, the building, the operation, to make the decision from the operator or for the industrial point of view. The plant will be operated during more than 60 years, so short-term is no relevant, and short-term profit is no relevant in the field of nuclear. Generally speaking, in the field of industry, energy industry, it's long-term area, and especially in the field of nuclear. Lesson number 3, we need to reinforce international cooperation between different actors, operators, safety authority, research institution. For research institution, it will be simple. Made more international programs looking at the resistance against earthquake, for example. For safety authority, a little bit more complicated. And for operators, they do already a lot inside the WANO, World Association for Nuclear Operators. Here is, for example, the number of peer reviews they organized, almost 400 in 2009 since the beginning in 22. This is, according to me, the best way to share the information and the best practices between the operators. Lesson also on communication. At least in France, what I saw as a citizen is most of the higher level responsible of the industry and of the public area come to the TV, radio, newspaper to explain as fast as possible according to the information they received from Japan. Of course, they couldn't give the information they don't have, but they give very largely the most information that was possible. And the lesson I personally take out of that is that it takes long to build confidence, and it takes short to destroy. I mean, you have to build the confidence, the trust with the public opinion when everything is all right. Then when there is a crisis, people, okay, listen to what you say because you have been transparent during the whole period where everything was going right. If you do not make this effort of building the confidence when everything goes right, it's difficult to have the confidence when something goes wrong. And last, emergency preparedness, which is perhaps a relevant topic for Hong Kong. I could observe very simply that concrete pump, fire trucks, military helicopters used in the emergency to cool the nuclear plant are not at all some nuclear devices. These are some civil security devices. So the responsibility when a crisis such as Fukushima occurs first is the responsibility of the utility, of the operator, of the owner of the plant, okay? But then the government has also a responsibility by this gathering of non-nuclear means to deal with the situation. And probably at a regional scale, such means could be mutualized with benefit. So just to conclude and to open discussion, a few points perhaps to suggest that this could lead to question and answer before I give the floor to Bertrand. Safety authority at the heart of the process somewhere to control. Zero risk does not exist. Think safety for the long term. And what's the balance between the economy of the system and why should we still build some nuclear plants, as I tried to illustrate with the gray circle and the red circle at the beginning. Nuclear is in no way the only solution. We have to think also of renewable, of saving energy, but it should be considered as an option because of its capacity of producing baseload electricity without CO2. And finally, the main aspect for me is human, because it needs time. I mean, for technical aspect, I agree also with Michael and with Malcolm on this point. When it's question of technical means, you can increase the speed by increasing the money. For human, it's not this way it works. The confidence, the communication, the safety culture, the skills building, the improvement process of the ethics, skillness, stakeholder literacy takes time, necessary time, and it's not a question of money, it's a question of, let's say, human aspect. This is, according to me, the main question we should work with, thanks to the forum today. Okay, that's what I wanted to introduce as a brief overview, and now, as it has been explained, our colleague from mainland China couldn't come for personal reasons, so I would like to introduce Bertrand Barret, who is coming from France this morning, as Christine says. So he's a scientific advisor in Areva Group, and he's also a very well-known teacher in nuclear engineering in France. He got his postgraduate in solid-state physics and then worked both in the public area as a counselor in the Washington Embassy and then in the private area in the nuclear field. He remains now a member of a number of international scientific societies, as well as I mentioned, a respected teacher in France in the field of nuclear engineering. So, Bertrand, if you want.